5 at the beginning.
Sounds good.
So, all right, without further ado, let's get to it. I think everybody that's going to present might be here. We have, well, welcome to IETF 110. Note thee well, this is the first session maybe some of you are at this week, so make sure that you read all this good stuff about understanding that we're recording this video. Anything you say at the microphone can and will be used against you. A lot of it comes down to having to deal with IPR. If you know about something and you contribute, you need to make sure you disclose that accordingly. If you have any questions about any of this, please feel free to ask Nick or myself or any of the other people that you see floating around a lot at the IETF. We'll be gladly willing to answer your questions. And that's Nick and myself. I see Nick is there too.
Hello, hello.
Okay. So basically, we're going to go through some administrivia. Then we're going to give Richard the majority of the talk here, the time. I wasn't sure if Raphael was going to present as well, because oftentimes you guys tag team it. Then we're going to go on and do some architecture discussions, and then have some time to talk about deniability. If we run out of time to talk about deniability, we are going to make sure that we have an interim that will address this topic, because it's been brought up a bunch of times, and we need to make sure we kind of get to it. The blue sheets are automatic, so if you're here, you've already been noted, so that's really nice. We have a note taker, that is awesome. I don't know if anybody actually goes in the Jabber room in this particular session, but if there is somebody in the Jabber room that's there and is also here, if you could just channel if there's any questions that come up. Actually, I think maybe the Meet Echo thing is plugged in this as well. So, all right, without further ado, let's go to the status slide. Basically, we were awaiting a new draft in the architecture thing till about an hour ago, and it popped up. So thank you very much, Benjamin. The MLS protocol I'll get to in a second, and the MLS Federation draft expired. I think we had some swapping of chairs of where people work, so we'll try to get that reinvigorated. But where most people are really interested is about the timeline for the MLS protocol. So at the last meeting, I showed this slide. The only thing really I did was move the bullet. This is "we are here." So the idea is that we're in this feature freeze to allow for interop as well as security analysis. And so then at the end of all of this, we're basically going to have, how do we do with interop? Could they get interop and security input from people to make sure that if we blew anything, that we needed to fix it. This is kind of the agreement we have with the security researchers. We're trying to get them to help us, and we get to make them famous by looking at our protocol before we publish it. We need to make sure we actually listen to what they say before we publish it. So that's really about it. The plan is that anything that we've changed as a result of interop or anything else that's come up, we'll end up having to put a new draft out and then spin a new version for working group last call again. And then we kind of like start to recycle down for draft 13 and others. Any questions? Great, let's get to it. Let me see now if I can actually share Richard's slides without blowing anything up. Stop screen sharing. Now enable it again. Yes, I changed my mind. And then go full screen. David Shinazi for making you want to do this. All right, cool. I'll hit stop.
All right. So the first slide, I've already screwed up. It's the wrong draft. I'll get the chairs an updated deck. So like Sean said, we are in our feature freeze and analysis period. So we issued draft 11 after a working group last call and some issue resolutions at the last IETF meeting. And since then, over the holidays and in Q1 here, we've been in a feature freeze and implementation timeline. We have at least 2 implementations going based on draft 11 that we have begun interop testing. I'll have some more comments on that in a minute. So today our focus is going to be a few issues and PRs that have come up during that feature freeze, mainly around pretty minor stuff, clarifications, some bugs people found. And so we'll talk, that'll be most of our time today. So next slide, please. Sean, next slide, please. There we go. Yeah, keep going past that one. Yeah. So word on interop testing. Oh. So we have kind of a cool interop testing framework, right? So we want to test various MLS libraries and assemble those tests in kind of a, and be able to test out various scenarios. It's a little bit more complicated than something like TLS, where you have a straightforward set up a connection scenario that you want to test, and maybe test it in various configurations, but it's always just like set up a connection from a client to a server. With MLS, you want to do things like have people join a group, do updates, do removes, do external joins, things like that. So we need a little bit more flexibility. So we set up this framework based on gRPC, where the Stack Center test can be gRPC servers, which means they accept RPCs, and we can have a test runners that can send RPCs off to these clients to make them do MLS stuff. So we've got two types of tests going here, test vectors and scenarios. The test vectors test kind of simple subsystems within MLS, and then the scenarios get to the actual whole protocol. And the test runner is set up so it automatically generates all these tests. So it kind of gets us some thorough test coverage of the protocol once we have a stack wired up into this harness. Next slide, please. So we have some very, during the kind of code sprint or hackathon week last week, MLSPP and OpenMLS teams got together and started doing some interop. We got a couple steps along this. So there's 5 levels of test vectors we got, and then some scenarios we got through the tree math test vectors. And just to the beginning of the key schedule, we have very basic interop. We verified that our derived secret implementations match. But then when we get to some more advanced cases, we start failing. So we're still working out the bugs there. Next slide, please. Just to show off what interop looks like. This is the output from our test runner, and the important line is that second one there. So the top and bottom lines are just the stacks interoperating with themselves, but the second line is first record of interop between MLS stacks. MLSPP generated some test vectors for tree math, and OpenMLS successfully consumed them. This is also, incidentally, our first interop failure, where OpenMLS didn't generate quite as many cases as MLSPP was expecting, and so MLSPP rejected that. But I think that's since been fixed over the weekend, and now we're interoperating at that level. Yeah, Sean?
Hey, Richard, are we going to save this so we can sell it for $2 million later? Sorry.
As long, yeah, we can use the NFT to fund the IETF. This will be in the archives, so you can choose to monetize it as you will. Next slide, please. So the usual MO with interop testing is you find bugs in the implementations where they don't align with the spec, and then you find spec bugs where the spec is unclear. And so far, all the bugs we found have been of the former category, where the implementations were not agreeing with the spec. And once we fixed the implementations and aligned them with the spec, things worked a lot better. So one of the implementations had the order of the inputs to HKDF extract and the key schedule swaps, and once they unswapped, everything worked fine. We had this odd case where the 2 stacks were interoperating on 2 Cypher suites, but not the third, and it turns out one of them had the wrong set of algorithms associated with that Cypher suite. It was generating like giant SHA-512 hashes instead of SHA-256 hashes. So once we fixed that again, things started to work better. So I haven't come up with any spec bugs yet. So, but obviously we're going to be doing some more of this, covering more of the surface of the protocol, and undoubtedly there will be some more bugs to be found. Next. So that's the interop report. Pause here in case anyone has any discussion of that. All right. Other than, oh yeah, Sean.
How many implementations were we talking about that actually got interop? Was it 2 or was it like 5?
Yeah, we started with those 2. We have, I think Chris Wood has expressed some interest in dusting off the Go implementation that we did earlier on. That needs some updating, but we have an easy way to plug it into the test runner. So as that comes up, we should be able to interop it pretty quickly. We have, if folks have stacks, we have example gRPC integrations in C++, Go, and Rust. So it should be easy to take your implementation and plug it into the gRPC-based test harness and do interrupt testing as soon as you get that hooked up. So we welcome more people coming along. I think the easiest thing to do is probably show up in the MLS implementations wire space and mention that you're working on stuff there. So yeah, glad to have more. I think we had a couple folks that were looking at this earlier on, and might need to dust off a few and update things to draft 11. But hopefully we can get a few more stacks here. All right, so this is just the list of changes that are in GitHub or expected to be on GitHub that have protocol impacts. So there are some editorial things that I have not listed here. But I figure we could go ahead and have some discussion and maybe come to some resolutions on these changes that result in substantive changes to the protocol. Like I said above, these are all pretty straightforward. They're pretty minor impacts on the protocol. So I think they're appropriate for the feature freeze and appropriate for kind of fixing and tweaks after that last call. So let's dive in. Next slide, please. All right, so this is just one thing that got lost. In draft 07, when we removed someone, if they were the rightmost member in the tree, we would truncate the tree so that we didn't have a bunch of unnecessary blank nodes hanging around. So the illustration just shows that if we had 3 people in the group and 2 of them were at the far left of the tree and 1 was all the way out at the right, when we remove that rightmost participant, we should also get rid of all of those unnecessary nodes that the 2 remaining participants on the left aren't going to use. That was specified in draft 07. When we did the proposal commit thing in draft 08, we lost it, and it is still missing, which I discovered when we had a bug in MLSPP with how we did truncation. I went to see what the spec said about it, and it turned out it wasn't there. So the proposal is here. We have a PR. I think that's 461 to just re-add this. I'm hoping this is not controversial. Unless someone stands up right now and complains, I think we're just going to merge this. TKG?
I was just raising the questions in the chat about why rightmost only. What's the like, why not symmetric? Raphael seems to be answering there, but I'm not sure I understand. But that may be just my own gaps in understanding.
Yeah, basically we have a constrained tree geometry here. Just to make talking about it simpler, it's the same tree geometry as in CT, coincidentally, but it's a left balanced tree, and so the tree always grows and shrinks to the right. All right, I think we can move to the next one. Consider this one approved, ready to go. This is an issue Raphael raised. He observed that we have this pre-shared keys in group secrets. So when you're adding someone in the group, you send them the group secrets. And one of the things you do is indicate which PSKs they should add when they are joining the group. Now, because PSKs are optional, we made them optional in the group secrets, but Raphael noted that this pre-shared keys is an array or vector and can also be empty. And so you have this ambiguous case where the PSK vector is present, but empty. And so the proposal here is just to simplify that syntax out so that the way you indicate that there are no PSKs to be used is you just send an empty vector of PSKs. So this is, again, is another pretty simple one. I think probably just merge this if people have no objections here. All right, hearing none, unanimous consent. Where's my parliamentarian to keep me on track here? So this one is, we've had a little bit of discussion today on in GitHub. I needed a little education from the proposer. This is from Eric Cornelissen, proposing to add the group context into the key schedule a bit earlier than it is right now. So right now, the group context gets added into the epoch secret, which is kind of below the bottom of this slide in the key schedule. The idea of this adding the group context in here a bit earlier is to ensure that the key schedules diverge faster in the case that the parties don't agree on the group context. That's my inelegant way of saying it. There's probably a clearer way. There's some discussion in the pull request that make it clearer, but the idea here is to get more context folded into the key schedule faster. I think this had a couple of approvals in GitHub. I was uncertain about it, but it seemed innocuous to me. So again, I think we'll just go ahead and merge this unless folks have further concerns with it. Active crowd this morning. All right, this one might need some more discussion. I'm hoping Conrad is on to contribute here. I don't see him, so I'm going to rely on Raphael, who I think is familiar with this. So right now, in the MLS group, we have a tree. It has a bunch of key packages that leaves of that tree, and each of those key packages represents a credential with an identity and a signature public key for the participant. Right now, we have no constraints on those on the uniqueness of those identities or public keys. So you can, in principle, have a group where every leaf of the tree represents effectively the same user, has the same credential, same identity, same public key. Don't know why you would have that in practice, and that's kind of why this comes up. So the proposal in this pull request is to have some uniqueness constraints on the leaves of the tree. So to say, if you see an ad, and it's an ad for an identity or a public key that's already in the tree, then you must reject that ad. So that we have a tree where every key has a distinct, or every leaf of the tree has a distinct identity and a distinct signing public key. Now, I think that's totally implementable in the way I just said. You just reject ads that would introduce duplicates. I think my concern here is with their constraint on identities. It seems, given multi-device, it seems plausible that you would have multiple appearances of a single identity with different public keys. So I would probably want to relax the uniqueness constraint on identities, but I could definitely live with a uniqueness constraint on public keys or on identity public key pairs. I don't know, Raphael, how does that strike you? Or Jonathan, I think see you got some comments in Jabber.
Yeah, I think the idea I had around that was that the identity, specifically in the multi-device scenario, could simply be extended with some device identifiers, so that you end up having a unique identity that the application can recompose and see that that belongs to one user. But that at the protocol level, we can absolutely distinguish the identity there.
Yeah, I have a bit of a challenge thinking how we might turn that into a hard requirement, concretely because the obvious way to write a requirement is a requirement on credentials. And you might imagine putting a device identifier in somewhere outside the credentials. So if you had, say, certificates, which have a very structured, constrained format, you might put a device identifier in, say, a key package extension, right? As a field where you can have more control, it's not as constrained. So if you were going to have a must here, and I see this, it says should in the title slide, so maybe we can leave it at should, and it'd be advisory. But if you're going to have a harder constraint here, you would have to find some way to cover both the credential case and the device identity being elsewhere case. But I think the
Fine with having the. Sorry, go ahead.
Yeah, sorry, go ahead, Raphael.
So you'd be fine with having unique signing keys, though?
Yeah, for sure.
I guess maybe I'm next in the queue. Ben Kaduk. So I think one thing to think about would be in terms of what are the uniqueness requirements for if you have one thing and you need to go to the other for identities versus keys. And it seems intuitive, at least, though I haven't done the analysis, that you've got the key is going to be signing a message or something like that. And so you probably do want the mapping from key to identity to be unique, so that you can say, this particular key corresponds to this identity who is what did whatever action. It's not intuitively clear to me that you need the uniqueness the other way, but I think there's probably some pretty strong reasons to want unique keys, at least.
Yeah, thanks, Ben. That's an interesting way to think about it. Martin?
So, the should is interesting. What's the interoperability consequence of violating the should? And if someone were to enforce a policy that said that the keys have to be unique, and that was not a universal policy, how would someone adding people to this group know that this is something that they would be constrained by? I think that applies more to the identities than it does to the keys. I think I'm coming to the conclusion here from the discussion that the keys need to be unique no matter what, but the identities might not be.
Yeah, that's a good point. I think the interoperability is a real challenge here. I think we could probably have, and it sounds like there's some agreement that we should probably have a hard requirement, must, that you must have unique signing keys per leaf. But that maybe the constraint around identity could be softer. You should have unique identities.
In which case you wouldn't be able to enforce uniqueness in any way. The expectation would be that that would just be something that people do.
Or it would be up to the application to decide what it means by uniqueness.
And everyone would have to then tolerate the fact that there could be two nodes in the tree with the same identity.
Yeah. It would be something, for example, that your MLS stack wouldn't enforce for you, to think about it that way.
Right.
So DKG, to your question, Java, the identities right now are arbitrary byte strings. They are represented by credentials, which have extensible types. There's a basic type which just carries a byte string. You can also put a credential, an X509 certificate in that slot, in which case you get a more structured identity. So it sounds like there, based on the chat, there might be a little bit more discussion of this, but it sounds, the conclusion I'm kind of hearing here is that we can have a must on uniqueness of signing public keys, and then probably some recommendations and should level requirements around uniqueness of identities. Does that sound about right to folks? All right, thanks for the discussion. I'll provide that feedback back to the PR author.
So on this particular point, I think it's probably important to make sure we get the security considerations right on what this means.
Yep.
Okay.
All right, so this is one, this is an issue that I believe Franciscus filed tonight. There's a corresponding PR that Joel provided. There's a kind of obvious problem and a broader suggestion. The obvious problem is just a missing word, which Joel's PR re-adds, that fixes an issue with the parent hash verification algorithm. There's also this request for a more formal description of the algorithms in the spec to reduce ambiguity. I don't know if Franciscus is on the call, or if Joel has talked to Franciscus about this. Knows what the objective is here, but yeah, I'm kind of unclear on what to do with this without further details. Martin?
last time. I didn't take myself out. Sorry.
Ah, okay. I don't know, Joel, Raphael, have either of you talked with Franciscus about this to have any idea what he's looking for more concretely?
In the meantime, but I think what you quoted there is the gist of it. We need to be absolutely sure that this algorithm works as such.
Yeah, I think what I might do is maybe we could kind of put this on hold until we get some interoperability going on TreeChem and parent hash validation, and see if we run into any interop issues as we're doing that would benefit from clarification. Kind of empirically test whether this is clear enough to get implementations that work together. So kind of mark this one. I'll merge the typo fix, and then keep the issue open pending interop issues. Sound good? Without objection. Well, you can proceed. Next one. There we go. Okay, so this one is a little complex. This is an issue that Britta filed. I don't know if she's on, it's a bit early her time zone. So when we introduced external commit, that was one of the last big changes we made to let people join from outside. External commit, you can add multiple proposals in there. So the major application of it is to add yourself, but you can also do things like adding other people or removing members of the group when you do that at the same time, as long as people are willing to let you do that. In particular, one of the things you can do is construct a resync operation out of this, where you delete the old version of yourself out of the tree, and in the same commit you add a new representation of yourself in the same external commit. In the issue, I think Raphael noted that if we have this uniqueness criterion, you can recognize this case now, right? Because the old self and the new self will have the same identity, presumably, at the top level, but maybe different device identifiers and certainly different public keys. So you can recognize when you are doing this resync operation. What Britta notes is that this is not quite as tight as it could be. By default, the new representation, the entity doing this external commit re-add resync doesn't have to prove that they were ever a member of the group in the past. You could if you had access to someone's signing key, you could do one of these operations. Not having access to any past history of the group. The obvious way to do this is to take a PSK that was derived from some earlier epoch. I think we've got a resumption PSK that might be usable for this, and then you would inject that into the new epoch using a PSK proposal in the external commit. And so I think the question here is, should we recommend or require that you have this proof of past membership in this resync scenario? It would require a bit more formality, kind of formalizing this resync operation. But I think we kind of have the tools to do it between identity uniqueness making the situation recognizable and the resumption PSK. So it would mainly be a recommendation, formalizing the situation and recommending what you do in that situation. Personally, I don't have a strong feeling about this. I open the floor if anyone else does. Oh, while people come to the queue, I'll note that the bottom bullet here, this does make a bit of an odd assumption about state loss, right? The point of resync is that you've lost your state associated with the group. You've desynced with the group, and you need to reinitialize from no state. But if we require that you have a PSK from earlier epoch, then you can't resync if you've lost that state. So we would kind of reduce the utility, the applicability of this resync operation to cases where you've lost most of your state, but you still have your PSKs around somewhere. I think given that operational thing, I think I might tilt slightly away from making this a requirement just to make the resync operation a little bit more general. That does have the, there's a trade-off here between applicability and requiring that you keep state around, you still have state around and not have to desync that state, versus allowing folks who don't have that state to rejoin. But yeah, again, open to feedback on where folks think we should land on this.
Yeah, this is Raphael speaking. So yeah, to that point, I think there is a valid case though where your state could get corrupted over time, because that simply happens in reality. And if you just flip one bit, then you're not able to participate in a group anymore, while your resumption sequence might still be perfectly valid. So that would actually still work. The other question here is, in reality, on a device, how well are the resumption secrets protected versus the signing key? Because if anything, I'd assume that the signing key is usually better protected than resumption secrets. So the question is, what kind of threat model is it exactly where an attacker compromises a device? I would assume that that attacker would get their hands on both the resumption secrets and the signing key in that sense. But I mean, I don't want to dismiss this. I think it's a very important thing to look into.
Saw Conrad pop up briefly, but Conrad, you want to have a comment here?
Yeah, can anyone hear me?
Yes.
Yeah. Yeah, I mean, it depends. I guess the resumption secret would be less likely to be on multiple devices, whereas you might use the signing key across multiple devices, which would extend the attack surface there. So, and also depending on the updating regime, you might be cycling between epochs and keeping your group states and your resumption keys fresh, but you're depending on the authentication that you use, you might not cycle your signing key all that much. So the signing key might not get regenerated. So if someone compromises you, they might have the signing key, and the signing key might be the same for forevermore, and then your resumption secrets might change over time.
So I'm not hearing a real strong movement in one way or another. I think we could certainly have a recommendation around this, say in security considerations or operational considerations, that if you're doing one of these resync operations, then you should include a resumption PSK. And I think you could also recommend that applications enforce this criterion, that if they allow resync in this way, then they should also enforce that a resync PSK must be present. But this sounds like it's kind of that recommendation level and not a hard requirement. So that would kind of be my proposal for addressing this if folks don't think there's a need for a hard requirement. All right, nobody's stomping on the ground to have a hard requirement here. We'll obviously have some discussion on GitHub as we get some concrete text here. That sounds like a pretty clear direction. All right, this is the last of the issues, I think. Hubert Tathi from matrix.org raised this on the mailing list, that there is some ambiguity around what group context you use where. With proposal commit, we basically isolated all of our complexity into one function call or two generating commits and handling them. In the process of generating or handling a commit, it turns out that you need to use 3 different group contexts for different operations. When you create or process an update path, you need to use the group context that represents the tree as as you're using it to create or process that update path, which means you've taken the old group context and you've applied the proposals, but you haven't moved forward the transcript yet. So it's this kind of intermediate group contexts. When you update the key schedule a little later on to generate the confirmation tag, you use the group context for the new epoch. Use it with the transcript updated and everything representing the new epoch. And finally, when you go to sign the MLS plaintext at the end, that needs to be verifiable by someone who's in the last epoch. And so you need to use the group context for the last epoch. So this is something that, it took me a while to explain here. You can tell this could be confusing to an implementer. And it's not super clear in the spec laid out how this works. So the proposal here is just to align, create some taxonomy that describes what each of these contexts is, and be real clear in those instructions where you use which one. So basically, we have and we have a specific group context per epoch, old, new, depending on which one you're pointing to in the context of a commit. And then we'll have this notion of a provisional one where the proposal has been applied, but otherwise hasn't been updated. This, hopefully is just a clarification. Hopefully aligns with how people were understanding the spec already. But wanted to put it up here in case folks had comments or concerns. This didn't align with what people were already thinking. Raphael, Conrad, you guys have been implementing. I think this is mainly just a clarification, so we'll get some text put together. Don't think this will really affect interop.
Yep, that's great. And I
All right, and then I think
is the last slide.
That is the last one. I just wanted to talk quickly about the next few steps. So I think we've got some interop testing going. We would love to have more implementations. Seems like we're on a track to kind of get that done in the next, the rest of this month. April is a generous ETA on getting interop testing done. At the end of that, I think we'll continue to target draft 11. We may let in, say, the truncation thing or something like that. Or maybe not. We continue to target draft 11 for interop testing. Then once we get to the, once we have things interoperating and have some good signs, land all the last PRs, issue draft 12, and kind of do that as soon as we have interop on draft 11. That means the interop time is also your time to get any last issues in that you would like done in the last round of interop testing. But I think before we issue the last call, we should probably take these last changes, which are fairly straightforward. So the updates to the implementation should be fairly small. So I propose that before we issue the last call, we should update implementations, revalidate interop, and then head on to last call. So it's kind of the map to completion. Love to get folks into the interop.
Is that essentially the idea that you'll work to an editor's copy on the GitHub repo before submitting it? Is that kind of the idea for?
Well, no, I think for interop, I would like to say we'll point to a stable reference. We'll point to draft 11, and then once draft 12 is out, we'll implement that and do that, and make whatever minor changes we need to make. But the editor, so the editor's copy on GitHub, as we merge PRs, will be in advance of what we're testing for interop. But yeah, I think that we have a realistic track to getting this out of the working group by summertime.
So my only caveat here is that we have to make sure that whatever security research we get back from the community gets reflected. I know you're plugged in pretty closely with them, so there shouldn't be any surprises, but I'm hoping that at some point we can have some kind of like, hey, these 6 people looked at it, these guys used Tamron, these guys used ProVerify, these guys did it by hand. We're basically good with, these 20 different caveats to go from there, because I think that if we're gonna, make this deal with the devil, to have the researchers look at our protocol before we publish them, we have to make sure that we explicitly acknowledge that we actually looked and took their input in. And that may require having another interim or something just to like formally go through that to give people a chance to say something or try to understand it.
Yeah, absolutely. Happy to address those. And I think Joel was maybe talking to some researchers to try and calibrate who's doing what and when we expect to see some results. Speaking of interims, I think there's already Brendan raised an issue on the mailing list this morning that probably merits an interim to talk about. So we should probably have a couple of calls to sort out any last issues as we get through this. All right, I think I'm done.
All right, I will switch over to the architecture draft. Hopefully I can do that without blowing it up. Share this. So Benjamin produced these slides somewhere like 20 minutes ago. So I just got them and just uploaded them. It's one of the things I was doing in the background. He unfortunately couldn't make it, so I'm going to go ahead and give the one slide. This should give plenty of time for Sophia. The 06 draft version was released today. Not surprising, I think, to me, but there was a whole lot more work involved, I think, than when he really thought. We were kind of planning for this draft to drop in January, and it kind of got pushed out. And there's still a lot left to do. We got a whole lot more security and privacy considerations of the document and some restructuring of the functional requirements as well. A lot of the changes really were just editorial and didn't really affect any of the previous decisions, which is good. And it's going to take some time to actually sync these two drafts. And the reason why I think that is important basically is because I don't think that we could drop the protocol draft in front of the ISG without the architecture draft. So if we need to speed up the architecture draft to get in line with the protocol document, people need to kind of start focusing and spending their attention on that. So the next step for the document, this is again the only slide, to determine what's missing should be moved or removed. And the way to do that really is to kind of kick stuff up on the mailing list and the repo. Please sync with the authors to make sure we can contribute everything all in a row and a good thing. If you have any security considerations, I think Conrad's being thrown under the bus here. So he's going to try to make sure that it's clear and makes sense to everybody. And also, I guess there's some use case. There's a use case section that Brendan has been looking at. We want to make sure that you reach out to him as well. And this is a nod to our other server assist document that we discussed adopting last January in 2021. That's with Raphael, and hopefully we'll get a draft out of that and maybe even adopt that in the working group. I'm kind of pinch hitting here. So basically it's open season now on the document, so let's go to it and try to make sure we can get the two of them synced. Any questions?
Yeah, I have a question, I guess, for you as the chair. Is this the sort of thing where we could be soliciting volunteers to look at specific parts of it, or do we really just need a holistic review by as many people as we can get?
I think it's probably, I'm hoping for the latter, where it can kind of happen organically, that if Conrad is kind of, corralling the security consideration stuff, that he'll be looking at, like, what else is also missing. And the same with Brendan looking at the use cases. But yeah, I get your point. At some point, we're going to have to be like, all right, raise your hand. You're going to go look at this. Please look at these sections. And maybe we can get that going for the next interim, which I hope to have it sometime in early April. And we can actually start to pin people down.
Sounds good. Thanks.
And yeah, if anybody feels like volunteering, feel free to get in front of a speeding bullet. All right. Going once. Going twice. Sold. All right, Sophia, you're up. I'll drive the slides.
Okay, thank you. I'll wait for the slides. Okay. Okay. Yeah, okay, so thank you very much for allowing me to talk today. My name is Sophia, I'm from Cloudflare, and today I'm going to be talking about deniability in MLS. So next slide, please. Yes, and a little bit about the context of why we want this. There has been, as Sean said at the beginning, there has been already some talks of having deniability. So finally, the idea was to sit down together and write something around it. And the idea to actually have deniability is because it has been considered a desirable privacy property and is currently supported by most of the other secure end-to-end messaging protocols. And on the past weeks, past months, I'll say there has been an increase of deniability in terms of, because sometimes the messages that we're sending through emails or to chat applications are strongly authenticated, which creates a strong proof of authentication, which can be later used for other purposes. So the idea is always to put deniability on top of authentication. There are other flavors of deniability that I will not be talking here because I will be only talking about deniable authentication. And just to refresh anyone, deniable authentication is this property by which it cannot be proven that a message has been authored by anyone in a conversation, as anybody could have potentially authored that message. It doesn't go against authentication, it's actually put on top of authentication. Next slide, please. Okay.
So, Sophia, if I could inject a quick question on the last slide.
Yes.
I would like to distinguish between two deniability notions. One, where the set of people who could have generated a message is the set of people in a conversation versus anybody in the universe. So
Yes.
it seemed like two pretty distinct notions. Are you targeting one or the other of those?
Yeah, that's precisely what I'm going to talk in this slide. Precisely because MLS is providing two forms of authentication. And the first one is this authentication in which you know that someone in the group sent a message, but you cannot pinpoint exactly who sent this message in this group. But it's also providing a second form of authentication and a stronger notion of authentication, because you can indeed pinpoint who sent this message in this conversation by the usage of digital signatures. So in the first case of authentication, in which you know that someone in the group sent this message, we already achieved some certain form of deniability, because you don't know exactly, you cannot pinpoint exactly who authored a message in that conversation. But the idea of this that I'm going to propose is mostly go to the second form of authentication, in which you're using digital signatures, and try to come up with a proposal to have a deniable weight for this stronger notion of authentication. I don't know if that answered the questions. I can go more detail in the next slide, actually.
That's great, thanks.
Okay, yeah, as I said, in the first form of authentication that MLS has, we already have a form of weak deniability, because no one can actually pinpoint who exactly sent the message on the group. We can say that someone in the group sent the message, but we cannot say who exactly. And the second notion of authentication is a little bit more difficult to achieve deniability, because as it has been pointed out, digital signatures actually provide a stronger notion of authentication, because anyone can publicly verify that a signature is authored by someone. In this case, the proposal that we came up with is to actually expire the signature, the private key corresponding to the public key of the signature. So then you can expand to say, like, indeed anybody who has access to this private key, who has been revoked, who has been revealed, could have potentially authored the message as well. Okay, so next slide. Oh, okay, I will wait a little bit. Okay, so what's the problems with this? The problems of this is when to exactly reveal the key. One of the problems that, for example, OTI in the version 2 had is that it was allowing people to reveal the key as a sender or as a receiver. And the problem with this is that if you reveal a key as a sender, then the authentication gets diminished, because the receiver of that message will not have the insurance that indeed this message was authored by the participant who was intended to be authored, but it could have been authored by anyone else. So at the end, for example, OTI in version 2 decided that only the receivers should reveal the appropriate key. The problem with this is that, of course, in a group chat setting, you cannot reveal the keys of the participants receiving it, because you are never sure when indeed the message has been received, because it could have been received by a participant at X amount of time, and then by another participant at X+1 amount of time. So you will never be sure when indeed the message has been received by them all. So that is like a no. So the idea that we came up with is to actually reveal the signature keys by something that is already stated in the protocol itself. So one of the things that is already stated is that the signature keys are exposed are shown to the messages of the group because they belong to the key pack. The credential belongs to the key package object in the leaf of the tree, and they can be expired because they have a lifetime valid extension, and because they also, sometimes you can revoke them because you change the signature algorithm or because the keys get compromised. So the idea is to use the same capability of the key packages to be expired or to be revoked or to be renewed, to have also this extension of deniability that every time frame that the extension decides, those signature keys will be rotated and the appropriate private key corresponding to the signature keys will be revealed. Something to think about more forward is also which kind of deniability this is. This is not a traditional deniability because you're not achieving deniability every time that you receive a message, but rather something that you, after you receive X amount of messages and after the application say, hey, it's time to revoke this message, then you actually reveal the key. So I'm somewhat more similar to what post-compromise security is. This is something like post-compromise deniability. And there's still missing the details to correctly define this property. Also, what happens to messages that arrive way out of time, but that arrive really delayed? In this case, those messages will not be strongly authenticated anymore because the key has already been revealed. But this is the same case of what happens if, for example, you rotate the key and you lose the access to the corresponding private key, or you change the signature algorithm and you update also that. So it's the same case. This is somewhat related also to what Richard was already talking at the beginning about signature keys being per device or being unique. In this case, it will be better if they are unique per device because it's much more easier to reveal a key per device rather than to coordinate between devices to say to all of them, please reveal your keys at the same time. So it's much more easier to do it per device as well. And if you want to look at the draft location and ideas, it is here. Please send issues or discuss further if you want, there or in the mailing list or here. And with that, thank you very much.
Oh, so
okay.
I think I left myself in the queue from before, but I also have a question here, so I'll go ahead and ask it. So does this draft? So I admit I haven't dived into this draft real deeply, but I think we can debate like whether this, what deniability we're getting, what the operational challenges are. What I'd like to ask instead is, regardless of what we're doing here, does this draft require changes in the base protocol, or is it just about how you use the mechanisms in that protocol?
No, it doesn't require changes to the main protocol. That was one of the ideas also, that it shouldn't change the main protocol that much. It will be added as an extension. So anyone who has this as an extension, then the keys will get revealed by the authentication service or what any kind of other application, but it's not changing the main draft itself.
Great, thanks.
Okay, so we've been talking about deniability on and off for I guess since the beginning of this working group. So what I'd like to do is try to get a sense. I'm going to try to do a poll. Can I do that real quick? Where do I do that button? No, I can't remember where I did that. Anyways, I'm going to basically try to take this to the list because it looks like this is something that we should be looking at. And we just have to make sure that we document any security considerations as you've got going there. So knowing that's one of your focus of your jobs, that'll be great. All right, so I think we're going to switch drafts here. We had a late breaking draft to talk about the crypto analysis of MLS. So if everybody can stay tuned for the next couple of minutes, I got a presentation from Joel. All right, Joel, you're up. Oops. All right, off you go. If you're talking, we can't hear you, Joel.
Yeah.
Can hear you now.
Yes?
Yep.
Hallelujah. Okay. I was getting nervous. Then I start clicking random buttons and it gets worse. So, all right. Yeah, I'm going to try and summarize a bit the the state of cryptographic analysis of MLS. And let me start by saying, you know, a real in-depth analysis of this is kind of out of the scope here. And so I'm just going to try and give you the high level and you know, ask whatever questions. So can we go to the next slide? All right, so yeah, so I'll start with a very high level, sort of the executive summary kind of thing. And then I'll get into a little bit more. I think I probably switched the order of these things, but anyway, let's start out. Next slide. All right, so if nothing else, right, then this slide is kind of the takeaway, I think, that this is sort of my summary of the state of all the different research projects. There's been a fair bit of work on this, and this is kind of my takeaway right now of where we stand. You know, this is not a precise thing. This is about confidence levels. But I would say we have strong confidence at this point in, from a cryptographic perspective, in the design of the protocol, the following properties of the protocol. First and foremost, I'd say privacy of content, okay? So this is like the application messages, okay? Those things, they're private. That's sort of goal number one that's been really analyzed here. Then we have authenticity of content. So that means if your client says this message came from Bob, it came from Bob. Transcript consistency is another property we've been analyzing in various guises. That means if Alice and Bob can talk, that means, well, if Alice receives a message from Bob and her client shows this message, she is now assured of the fact that Bob and Alice have the same view of the history of this conversation. So their transcripts of the conversation are consistent. Consistency of group management is another one. So Alice and Bob, if they're talking to each other, can be assured that they have the same view of the state of the group. If Alice thinks Charlie's in the group, Bob thinks Charlie's in the group. And same for if Alice thinks Dave is not in the group, then Bob also thinks Dave is not in the group. And Dave can also not read messages. So these are kind of the four intuitive properties that I'd say we've really analyzed quite thoroughly at this point. The other part of that equation, though, is not just what you're getting, it's against what kind of attacker you're getting in, right? So sort of the type of attacker that, you know, more or less we've been looking at, you can think of them, well, they're extremely powerful on the network side of things, okay? So they're manning the middling all traffic here. They basically own the delivery server. There is no distinction between the delivery server and the attacker here. They can schedule packets at will. They can drop packets, modify packets, right? So network side, super powerful. In some of the most advanced security models that have been considered, we're also looking at insiders. Okay, so these are participants in legitimate participants in groups who are trying to use their view of this group state to do bad things, like break privacy of content in some other group, or even an artificial group that they created and then invite people to, right? This is the insider side of things. This is why MLS does blanking, for example. It's because we're worried about insiders. Then another thing these type of attackers can do is we give them the ability to compromise group members, which means, specifically, it means they can say, okay, Alice's cell phone, I want to know everything that's on Alice's cell phone. And of course, you know, there are limits then to the security we get, because you can't ask for privacy the moment they compromise Alice's cell phone, but we show that the PCS part of MLS works well. And then, in other words, even though they're compromising first Alice, then this, then that, then this, the protocol is constantly healing itself, and we show that this mechanism works quite well. It really does heal itself quite well. And another capability of the adversary that we've been looking at is what happens if the adversary can start registering keys in the PKI, right? So on the one hand, there's the signing keys, and then there's also these key packages. So we've sort of been looking at, well, let's give the ability to the adversary maybe to compromise, you know, working sort of in concert with these key servers. What security properties do we still get if the adversary can do these things? And remember, there's this notion of certificate, right? So if the adversary doesn't have the ability to compromise a certificate, make a fake certificate for some key it registered, doesn't necessarily matter that much that the adversary can register these things, because all honest clients want to be checking certificates. So that's kind of our root of trust, is the certificate, not the key server itself. And that's great, because this is in line with this end-to-end mentality here. And the crypto has reflected this and showed that as long as your certificates are secure, the key server, we're not really relying on them. They're just basically another distribution channel. But it's the certificates that matter, which is good, because that's kind of the intuition I think I at least had. And I think that's played out in the crypto analysis.
Hey, Joel,
So
I think, yeah, so that's good. I just gotta say, I think we're at the end here, basically. So unfortunately,
Good.
the way this worked out, I have to go real quick. Go real quick.
All right, well then, yeah, so skip this. You can skip this slide. Next, yeah, so then one of the things to keep an eye out for is that because MLS is so complicated, these analysis oftentimes focus on subsets of this whole protocol stack. So that's one thing that differentiates some of the research. You can go to the next slide. One of the main focuses has been this thing that people are calling a continuous group key agreement, which kind of encapsulates TreeChem, but also the stuff around TreeChem that makes it more authentic, that authentication mechanisms like the confirmation tag, the MAX, that kind of stuff. And we bundle that all up into a protocol it's inside MLS. It's called continuous group key agreement. And the functionality it provides is you essentially manage your group, so you can add people, remove people, update, but you don't get all the way up the application, the key schedule. It's just every epoch you get a symmetric key. And this symmetric key is only known to group members, and you want PCFS for this. And so this has been a lot of the focus has been on this, because once you've got that, going all the way to secure group messaging is not that much more complicated. You basically need it's not trivial, but you really just need this symmetric key schedule, which is lots of HKDFing, and then an AEAD. So a lot of the analysis is focused just on the CGKA part, because it kind of captures the core of what's hard. Next slide. Some of the work, though, has actually focused on trying to really do full stack MLS. Some that's going to come out. Karthik Benjamin and I'm not sure, sorry, Meldrum, I don't know his first name, have done also really interesting. They did full stack but the version 7, they're just in the works of updating that to the current version. And one thing I really like about their work is it uses automated proof tools, right? So that's quite different than most of the other work, which has been pen and paper proofs. And so I really like that we're doing both, because the automated really gives us this high level of assurance in the quality of this proof. And the pen and paper is really good at explaining why things are secure. What is it about the MLS protocol that gives us this property or that property, rather than just certifying that it does give the property? And that's good if we want to start understanding how we modify it. So they're quite complementary. Yeah, so that's another aspect of how the research has been going. Next slide. Yeah, so these are kind of the culminations, I think, are these two papers that just sort of look at the strongest models. Next slide. And really, they're focused on malicious insiders. And yeah. So for insiders, I did have this slide here. I don't know how we are in time, but I wanted to get a little more into what these capabilities are, because really that's kind of the goal that the crypto has been mainly focused on. So we want to understand, what is an insider attacker? And I guess most of the things I've said already: network full control, insider participating in legit groups. PKI can register keys at will, but so there's no assumption about proof of knowing your secret key. That's a common thing PKI sort of assumes. We don't need any of that. He can register your public key as his own if he wants, even if he doesn't know your secret key. So that's really good. Means very weak assumptions about our key distribution stuff. Fully adaptive, can make all his attack decisions on the fly. That makes things very difficult often to prove in crypto, but that's how things have been done. Drives the execution. So the adversary in these models gets to drive, says, Alice, you need to add Bob to group X. Charlie, you need to remove yourself. That's also good because it shows that even if the attacker gets to have like the lucky execution, which basically he's driving, it's not going to help him here. Gets to corrupt users. And one other thing we've looked at is RNGs, susceptibility of MLS to bad RNGs, leaking of random coins, even going all the way to the point where the adversary gets to decide, okay, Alice, your RNG is going to output this string next. So we've also been looking at how MLS behaves against that. There's actually a PR coming up that might strengthen things a little bit, and that's a result of this hardening against bad RNGs. But of course, there's limits. And this is where the model says, well, these are your trust assumptions. You got to make sure this stuff holds. The adversary cannot make fake certificates. The crypto cipher suite you're using is secure. And, you know, we do assume things like this is crypto, not security. So we're not doing things like, okay, the adversary can't exploit vulnerable, like whatever, a buffer overflow in your stack or something like, you know, that's out of scope for the crypto analysis. Timing attacks is also something we haven't looked at yet. As far as I know, no one's looked at. So those are the limits of what's been looked at. Next slide. So this is the last slide. This is my musings on where to go, what other like crypto research would be nice to have. Yeah. So metadata security. As far as I know, no one's really looked at that. MLS clearly considers it. Otherwise, why do we have MLS cipher suite? Why is not everything being, you know, why is our wire format not just MLS plain text? Well, because we might very well care about metadata security, encrypting headers. I don't know any analysis about that at the crypto level. The automated analysis from Benjamin, Karthik, those guys, that's lagging a little. That's going to be updated to MLS version 11. Really looking forward to that. Post-quantum analysis, further out on the roadmap, we've said we want to support post-quantum. We have a PQ cipher suite, you know, that option is there, but there's no analysis yet, right? There's no quantum random oracle security analysis. If you plug in a post-quantum secure cipher suite, do you really get post-quantum security? We don't know, right? And probably yes, but no one's done the analysis. And of course, analyzing the more advanced features of MLS, right? We got these PSKs that we can mix in, external commits. We want to maybe upgrade cipher suite or protocol version mid-session. These kind of things, as far as I know, have not really been analyzed in some crypto sense. So yeah, I think that's all I have to say about that.
No, I mean, thanks again for this. And I guess having gone through the TLS reviews, there's a bunch of caveats that always happen. And we appreciate any work that you and your compatriots do before the ending of the protocol. And again, like I said, I think we need to make sure that we understand the input that's provided, so we make any changes to try to mitigate anything, because otherwise there's kind of no point in you guys showing up early. So thanks. And that wraps us up. Like I said, we'll probably try to have an interim. I'm going to shoot for early April to try to address. I know Brendan's got some issues. We should probably go maybe more in depth on this security analysis stuff and any additional changes on the protocol and architecture draft. So stay tuned and let's move it to the list. Thank you very much.